in the event that we erase the boundaries. The most captivating celestial body I recognize is the one that might be extraordinary in our sky. It is this one, Betelgeuse. It's a massive red supergiant star, and if you were to position it where our Sun is, it would extend all the way out to the orbit of Jupiter. This massive, extremely unstable star is on the verge of exploding. It's not as straightforward as it may seem. In the cosmos, there may appear to be these enormous events, like the most extreme supernovae, that could shake everything we observe, and even things we don't, though we cannot see it clearly. Betelgeuse is considered a symbol of a red supergiant star, typically much larger than our own Sun. Brian Cox, along with other astronomers, believes it might explode in a supernova soon. People have grown increasingly concerned about what's going to happen because the James Webb Space Telescope has been capturing remarkable images of the star. When exactly will Betelgeuse erupt into a supernova, and how significant will the impact be on Earth? Let's delve into a star in the magnificent Orion constellation, which shines so brightly that even ancient civilizations noticed it. The splendid star, Betelgeuse, resides on the eastern shoulder of the Orion constellation, ranking as the second largest star in Orion. Its name derives from this location, marking it as a shoulder star. Betelgeuse is likely one of the brightest stars visible in the night sky. In addition to its brilliance, the star emits an unusual red hue, which, as we will explore, signals potential danger. Humanity has long studied Betelgeuse. It was observed by TMY, a Greek astronomer, a long time ago. The first thing that people recognized about stars was their color. TMY noted that the star seemed to have a reddish-orange hue, an alarming indication. In recent years, scientists have been studying the star with even more precision, and they now have a much clearer understanding of what makes it so dazzlingly bright. One of these factors is that the star undergoes significant differences in brightness, fluctuating by as much as 0.6. Betelgeuse is a variable star, meaning its brightness changes periodically. In 2019, researchers discovered some new behaviors of the star that had never been observed before. Even though Betelgeuse didn't stop shining completely, its luminosity significantly decreased. It dimmed to a level of around 1.6, prompting experts to investigate why such an irregularity was occurring. In one of the brightest stars in the sky, they were hoping to find an explanation for why Betelgeuse was behaving so erratically. According to their findings, Betelgeuse could explode as a supernova at any given moment. Brian Cox, a renowned scientist, shared this alarming assessment. As a distinguished professor of particle physics at the University of Manchester and a Fellow of the Royal Society, and as a professor for public engagement with science, his opinion carries weight. He also presents popular science TV shows and writes books, making his perspective well respected. Brian Cox explained that Betelgeuse seems to be set in the future, a bomb that has the potential to explode quickly. To support this claim, the James Webb Space Telescope has provided substantial evidence. Although several peculiarities about Betelgeuse have raised many questions. Why does Betelgeuse act so strangely in terms of its variability? With the new data, Betelgeuse has established itself as a candidate for a supernova. However, researchers still don't know when the explosion will take place. The fact that Betelgeuse's mass is nearly twice that of the Sun supports this classification. Generally, stars with at least several times the Sun's mass are considered to be candidates for supernovae. The plot thickens though, because scientists have investigated, using various tools, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to investigate the star's mysteries. What they've uncovered is still shrouded in uncertainty. Betelgeuse was mysteriously born on August 31st, a very long time ago, and since then, the star has been offering strange signals that keep its future uncertain. What did they discover? They detected peculiar light waves emanating from the star, which raised further intrigue. But this wasn't the only bizarre incident. This brings us back to the fact that Betelgeuse is a variable star, fluctuating in brightness. There were reports that Betelgeuse had regular darkening episodes, akin to sunspots on our own sun, but the cycles were different. It shifts between bright and dim phases, twice as rapidly as it once did. Another odd sign that Betelgeuse is misbehaving. Researchers observed that in February 2021, the star's dimming cycle reached a brightness band of 1.61. This occurred shortly after the star had experienced a significant event of dimming, marking the beginning of its abnormal behavior and raising alarms that Betelgeuse might be nearing the end. The significant dimming between 2019 and 2020, reaching its lowest level, made many experts convinced that the star would explode within the next 100,000 years. But when Betelgeuse brightened once more, after this unprecedented dimming, things got even more confusing. Physicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics noted the star was now 150% brighter than usual, making it the seventh brightest star in the sky. Researchers were astonished to see a red glow emerging from the southern part of the sky. The situation only became more baffling. This development brought about numerous theories about the cause of the great dimming of Betelgeuse. It's essential to highlight that not every star radiates the same red glow that Betelgeuse leaves behind. Betelgeuse, as a red supergiant star, is in the final phase of a star's life before its death. This red hue is the result of a surface, temperature around 3,500 Kelvin, significantly cooler than the outer layer of the Sun, which is around 5,500 Kelvin. Since Betelgeuse is cooler than the Sun, it radiates less energy per unit of surface area, even though it is much larger and on the brink of exploding. We should also take into account the extraordinary dimming event that Brian Cox questions. Does it really mean Betelgeuse will go supernova? The fact that Betelgeuse is already in its red supergiant phase indicates that it is nearing the end of its life as a star. A star in this phase will often dim as it dies, and this is something scientists can detect. However, Betelgeuse's recent unusual behavior has caused scientists to concentrate even more on monitoring it. Today, multiple telescopes are focused on this mysterious dimming event, trying to gather more insights. Things continue to get even more intriguing, since researchers do not yet possess a comprehensive understanding of Betelgeuse's behavior. Utilizing cutting-edge instruments, researchers are keeping a close eye on the star. The James Webb Space Telescope has been one of the most useful instruments since its introduction in 2021, helping astronomers gather new and useful information about Betelgeuse. The telescope's images of the remarkable dimming have shown that the event caused an enormous mass ejection, roughly 400 billion times more significant than a typical coronal mass ejection. The James Webb Space Telescope can also observe things that are invisible to the human eye, such as specific wavelengths of light and frequencies, making it an invaluable asset. Researchers have observed dust clouds forming on the star's surface that appear to resemble leaves in space, an odd but fascinating finding, despite the fact that Betelgeuse is undoubtedly approaching its demise. Scientists continue to watch for signs of when it will finally explode. As no one knows the precise moment, Betelgeuse is believed to be significantly larger than the Sun, and scientists anticipate this brilliant red star to shine for the next decade. However, given the strange behavior of the star, it is hard to say if this forecast will hold true after the major dimming event. For the time being, scientists do not anticipate that Betelgeuse will explode in the immediate future. Though when it does, it will be the first supernova witnessed in modern times since Johannes Kepler's observation in 1604. Scientists don't believe it will occur quickly because they are still trying to understand the star's erratic behavior. Despite this uncertainty, when Betelgeuse does eventually explode, it will be an extraordinary and rare astronomical event. When it finally goes supernova, it will emit an immense amount of energy, briefly shining brighter than the entire galaxy, which can be seen, even from Earth, as bright as the full moon. Though the supernova will be an awe-inspiring cosmic event, it will not pose any direct threat to Earth because Betelgeuse is over 600 light-years away. Nonetheless, it will provide a valuable opportunity for scientists to study the final stages of a massive star's life and the phenomena associated with such an explosive event. Betelgeuse's inevitable demise is not just a scientific curiosity, but also a reminder of the vast and unpredictable nature of the universe. Stars, like Betelgeuse, play a crucial role in the life cycle of galaxies, enriching the cosmos with elements essential for the creation of new stars, planets, and potentially life itself. The death of such a star is not an end, but a transformation, as it releases heavy elements that will seed new stellar systems. While scientists continue to observe Betelgeuse, they are piecing together its future puzzle. With each new discovery, the mystery surrounding it grows deeper, expanding our understanding of the universe. With every piece of the puzzle uncovered, perhaps in the years to come, we will witness one of the most extraordinary events in the cosmos, the transformation of the massive red supergiant Betelgeuse into a breathtaking supernova. Until then, the sky will remain a canvas of wonder, with Betelgeuse shining brightly as a reminder of the fleeting nature of life in the universe. Betelgeuse's transition into a supernova is an occasion that will capture the attention of astronomers and sky viewers alike. Despite our uncertainty about exactly when this transformation will occur, the star's current instability has sparked a wave of speculation about its future. The advanced instruments and technologies at our disposal, such as the James Webb and Hubble Space Telescopes, have given astronomers unprecedented insights into the behavior of this remarkable star. As Betelgeuse's brightness fluctuates and its erratic changes continue, scientists are carefully examining the data in hopes of understanding what triggers these shifts. The star's extreme variability could be a precursor to the violent explosion that will ultimately mark the end of its stellar life. Whether or not Betelgeuse will explode within the next few years or in a much longer time span remains uncertain. One thing is abundantly clear: cosmic surprises await, and Betelgeuse's eventual demise will be a spectacle that brings new opportunities for discovery. Throughout the centuries, astronomers have observed and studied countless stars, but few have garnered as much attention as Betelgeuse. Its immense size, variable brightness, and unusual color have made it a subject of intense research. As a red supergiant, Betelgeuse is already in the final phase of its life cycle. The star's massive size means that it will eventually exhaust its nuclear fuel, leading to its ultimate collapse and subsequent explosion into a supernova. This explosive event will release an incredible amount of energy, significantly altering the surrounding cosmic environment. Despite the many uncertainties surrounding the exact timing of Betelgeuse's supernova, astronomers agree on one thing: the star's eventual demise will be one of the most important cosmic events to occur in our time. The data being gathered by the most sophisticated telescopes today is helping to unravel the mysteries of the star, providing crucial information about the processes that occur during the final stages of a star's life. By studying the behavior of Betelgeuse, scientists can gain deeper insights into the general workings of stellar evolution. Moreover, the explosion of Betelgeuse will likely leave behind a lasting impact on the surrounding space, enriching the Yahsai interstellar medium with heavy elements that will eventually be incorporated into brand new planets, stars, and potentially even life forms. This creation-destruction cycle is a fundamental aspect of stellar life. Betelgeuse's supernova will be a prime example of this cosmic process. As we continue to monitor Betelgeuse and other stars in similar stages of evolution, astronomers are using cutting-edge technology to better understand the forces at play. The James Webb Space Telescope, with its unparalleled ability to observe distant objects in the universe, is providing a wealth of data that will shape our understanding of stellar dynamics. The images and measurements captured by this telescope are helping to shed light on the intricate mechanisms that power a star's evolution, from its birth to its finality. Despite the fact that the death of a star may seem like a cataclysmic event, it is, in fact, a crucial step in the ongoing cycle of stellar evolution. The elements released during a supernova aid in the formation of new stars, planets, and potentially even life. In this sense, the death of Betelgeuse, and stars like it, is not an end, but rather a transformation that fuels the birth of new celestial objects. As a result, Betelgeuse's supernova will play an important part in the ongoing evolution of the universe, contributing to the creation of the components for future generations of stars and planets. Until the day Betelgeuse finally explodes, astronomers will continue to observe and study its behavior, piecing together the clues that will assist them in predicting its future. The star's unpredictable dimming and brightening cycles, as well as its other unusual behaviors, make it a fascinating subject of study. With every new discovery, scientists are learning more about the processes that govern the life cycle of stars, and consequently, the evolution of the universe itself. The mystery surrounding Betelgeuse's fate serves as a reminder of the vastness and complexity of the universe. The universe is filled with untold wonders, and the study of stars, like Betelgeuse, allows us to glimpse the incredible processes that shape the fabric of reality. As we continue to explore the cosmos and deepen our understanding of the forces that govern it, we are reminded of the fragile, transient nature of life itself. Betelgeuse and other stars shine brightly in the night sky, offering us the opportunity to explore the extraordinary, ever-evolving universe in which we live. As the study of Betelgeuse continues, astronomers are uncovering more details about its complex nature. The star's vast size and unstable behavior offer valuable insights into the life cycle of massive stars. The process of stellar evolution is both awe-inspiring and mysterious, and Betelgeuse provides an outstanding case study because of its proximity and peculiarities. One of the most fascinating aspects of Betelgeuse is the potential for its supernova to not only affect the local cosmic environment, but also to provide an extraordinary chance to observe such an event in real time. With modern tools like the James Webb Space Telescope, scientists can now examine the star's surface, its behavior, and surrounding dust clouds, allowing them to refine their models of stellar death. Such observations are essential in understanding the immense forces at play as a star like Betelgeuse transitions from a red supergiant to the explosive phase of its life cycle. The eventual explosion will create a shock wave that will travel through space, influencing nearby regions. This process enriches the interstellar medium with essential elements that play a role in the formation of new stars and planetary systems. Ultimately, the death of Betelgeuse will contribute to the ongoing evolution of the universe, underscoring the interconnectedness of cosmic phenomena across vast distances.